going to review the research process and demonstrate the steps involved so that you can get a better idea of the work you'll be doing this semester. Recall that last semester you began the process by developing your research topic, developing your hypotheses, and determining your methodology. This semester you'll be doing data collection, data analysis, and reporting your results. I'm going to be doing a very small study so that you can see all the steps involved and understand how they fit together. In this study, I'm interested in whether men and women like their jobs equally well. I'm also interested in finding out whether people who like their jobs more would also say they're less likely to quit if they win $5 million as opposed to people who like their jobs less well. One of my research or alternative hypotheses is that there's a relationship between gender and liking one's job. The null hypothesis is there's no difference between men and women in terms of how much they like their jobs. My other research hypothesis is that people who like their jobs more will also say they're less likely to quit if they win $5 million versus people who say they like their jobs less. The null hypothesis is that there's no relationship between how much people like their jobs and the likelihood they would quit if they won $5 million. Recall that the research or alternative hypothesis is the statement the researcher makes about the relationship between the variables in the study, which is to be tested. And the null hypothesis is the statement that there's no relationship between the variables in the study. I will be interviewing people. In this case, I'll be using a convenience sample, namely people who come to our annual Christmas party, who volunteer, or who can be easily bribed with cookies. Recall that a convenience sample is a kind of non-probability sample, so the people I choose to interview may not be like people in general, and that limits my ability to make inferences from this sample. To measure how much people like their jobs, I'll use a rating scale of 1 to 10, where 1 is totally miserable all the time, and 10 is deliriously happy every moment. I will define people who like their jobs as those who give a rating of 7 or higher. I will also record the gender of people I interview. The 2 questions I will ask are, on a scale of 1 to 10, how much do you like your job? And, if you were to win $5 million tomorrow, would you stay on or would you quit your job? Let's see what happens. How much do you like your job?
1 is miserable and 10 is deliriously happy.
That's okay. 1 to 10.
Probably 7.
Okay.
A 6.
A 6.
9.
9. Okay.
So,
A 7. A 3. 2. And
6 is probably where I am, so let's do a 6.
A 6.
Yeah, some people get back in line again.
I would have to say about an 8.
And if you were to win $5 million tomorrow, would you quit your job?
No.
Yes.
I would actually stay.
You would stay?
Absolutely. I would quit.
You would quit?
Yes.
5 million. I've done the math. I think 5 million is about right. I think I would probably quit. Yeah.
No, would you? You would. Yes. You would so quit. You would quit. Okay. So you would stay for some length of time.
I would definitely try to quit.
Okay. Thank you very much.
Thank you.
Now I'm going to begin recording data in my data file. I'm using SPSS, and the first thing I want to do is go to the Variable View tab and set up my 4 variables. My first variable is name. Normally I don't track name, but I want you to see the connection between the people I've interviewed and the data set that I'm creating here. Name will be a string because it's not a number. I can't recall how long my longest name was, but I'm going to leave 12 characters for that. Then my next variable is gender. And that too will be a string with 1 character. And over here in the values column, I'm going to specify that M means male and F means female. Then I'm going to put in the ratings that people gave me of whether they like their job. I'm going to call it like job. It will be numeric. I'm going to take the decimals down to 0, and I'm going to make the width 2, because the ratings can go up to 10, which is a double-digit number. My last variable will be stay. That will also be a string variable, and the values will be yes and no, depending on whether people said they would stay at their job after they won $5 million. Y will be yes, the person will stay, and N will be no. Now that I have my variables set up, I can switch back to data view and begin entering my data. Each person I interviewed will become a row of data. The first person was Tammy. Female, that's an F, and she said her job was about a 7, and she would not stay. My next person was Andrew. Male, rating of 6, and yes. I did interview some other people that you didn't see on the tape, and I won't put in their names. Name is not essential here since it's not going to be part of my analysis, but I will enter their data. Now that I have my data set up, the first thing I'm going to do is produce a histogram, which is a nice way to see how your data are distributed. Under Graphs, I choose Legacy Dialogues and then Histogram. In this case, my variable is like job, and I click OK. And the resulting graph looks like this. Basically what I see here is that one person gave a rating of 1, one person gave a rating of 2, and one person gave a rating of 3. Nobody said 4, nobody said 5. I had 2 people who said 6. By far the most common response was 7, which was given by 5 people. 2 people gave an 8, and 2 people gave a 9. So what I'm seeing here is that most people say they like their job. That is, they're higher than 5. Very few people gave low ratings. We'll talk more about data distribution later on in this class. It's an important concept because many statistical procedures require the data to have a normal distribution, which looks like this. If your data has a normal distribution, then as you add each of the values into your histogram, you should see a normal curve taking shape. Now that I have my data entered, I'm going to test my first hypothesis, namely that men and women differ in the mean ratings they give for how much they like their jobs. To do this, I'm going to go to the Analyze menu, and under Compare Means, I'll choose the Independent Samples t-test. In this case, I'm testing the variable like job, and I'm grouping by gender. I need to specify here under Define Groups that group 1 will be males and group 2 will be females. Here on the output screen, I see the results of my test. The males had a mean of 6.86 and the females had a mean of 5.57. So I'm seeing a difference in the 14 people in my sample. This output is the results of the independent samples test. And to interpret this test, I'm going to read the results for significance. You see one here and here. The significance level, which is also called a p-value, tells us the likelihood that the difference we see in the sample means there's a real difference in the population. A p-value of 0.5 means there's a 50% chance that the difference we've observed is true for people in general. A p-value of 0.25 means there's a 25% chance that the difference we see is true for people in general. Statisticians usually regard a p-value of 0.05 as significant, which means there's a meaningful difference between the people in the population. The first line here, equal variance is assumed, with this significance test. Basically, this is an assumption you need to correctly interpret the results of your test. And because the significance level is higher than 0.05, we can use the line equal variance is assumed and read on over. This significance test is the actual result of my t-test, testing my hypothesis. And because it's 0.354, higher than 0.05, that means there's not enough evidence here to conclude that the differences I saw between men and women in my sample were indicative that real differences exist between men and women in general. Now I'm ready to test my second hypothesis, whether there's a relationship between how much people like their jobs and whether they would stay or leave if they won $5 million. I'm going to test that hypothesis in a similar way with the independent samples t-test. Compare means, independent samples t-test. Again, my test variable is like job, and this time my grouping variable will be stay. And I have two groups, people who said they would stay, indicated by a Y here, and people who said they would not stay, indicated by an N for no. And here's my output. Only 3 of the 14 people said they would stay, and the mean rating they gave was 7.67. 11 people said they would not stay, and the mean rating they gave when asked whether they liked their jobs was 5.82. Then the independent samples test tells me whether the difference I'm seeing here is statistically significant. That is, whether the difference I saw in my sample is really indicative of a difference in the population. The first line here, equal variances assumed, is testing an assumption. And because the significance level is again greater than 0.05, we can reasonably expect that assumption has been met, and it's legitimate for us to use the results on this line. My significance level is 0.27, again higher than 0.05. So we can't really conclude, based on this evidence, that there's a difference between people who would stay and people who would leave in how much they like their jobs. It may be possible that my research hypothesis is actually true, but I wasn't able to collect enough evidence to demonstrate that. It's entirely possible that there are very slight differences in the way men and women feel about their jobs, but because those differences are so small, I wasn't able to detect them. The magnitude of these differences in real life is called the effect size. Differences with a small effect size are more difficult to find than differences with a large effect size. By analogy, it's like you're on the ground looking up at two big buildings. If the buildings are pretty similar in height, it'll be hard for you to see a difference from the ground. However, if the buildings have a great difference in height, it'll be pretty easy for you to see it. A similar effect occurs here. If the average between women in the real world and men in the real world is very close, say the average for women is 6.1 and the average for men is 6.2, then you'll have a hard time seeing it if you use a small sample size. However, if the average is much greater, say 3.3 for women and 8.9 for men, then you'll have an easier time finding it, even if your sample size is small. Another reason I may not have found evidence for my research hypothesis is that my sample size was too small. Sample size and effect size are both factors that can affect the likelihood that I will reach a correct conclusion from my study sample. So how many people do you need in your sample? That's not a simple question because the number you need is directly related to the effect size of the relationship you're studying. That's called statistical power, and we'll talk more about it later in the course. For these reasons, researchers never say they're sure the null hypothesis is definitely true. They always allow for the possibility that the research hypothesis was true, but their study did not produce enough evidence to confirm it. So for my study, I would write, this study did not support the hypothesis that there were gender differences in the extent to which people liked their jobs. The gender effect was not statistically significant. Neither did it support the hypothesis that there's a relationship between how much people like their jobs and whether they would quit if they won $5 million. The limitations of this study were that the sample size was very small and a convenience sample was used. This was a quick overview of the research process you will be conducting this semester. We will discuss each step in much greater detail, but I wanted you to see how all the steps fit together and how they can enable you to answer your research questions.
Research process you will be conducting this semester. You will discuss each step in much greater detail, but now you see how all the steps fit together and how you can use the process to answer your research questions.